Well, hello guys, here Mr. G with another question. This time we're going to be working with another question for the grade 10 related to energy. And this one is, or was question 5 done in the Eastern Cape province in 2022. I'm going to leave the question in the description below so you can solve the question before watching the video. The question says a man with a mass of 68 kilograms. So the mass of this man, which in the picture you cannot see properly, let's redraw the man. There is a man there. And the mass of that man, the mass of this man is equal to 68 kilograms. Okay? So a boy floating under the bridge, which is 50 meters above the top surface of the water. You can see the 50 meters, but let's make it in this color so we can see it better. So the height from the bridge to the water here is going to be 50 meters, and there is a boy in the water. He makes a bungee jump from the bridge. Ignore the effect of air friction. And here in the water, then you can see that is a boy struggling to get out of the water. So the boy is there. You can see the hands up there within the water. Okay. Now, the first question, 5.1, calculate the gravitational potential energy of the man just before he jumped from the bridge. So they want to calculate the gravitational potential energy of the man at that specific point. So we can do it on this side. And this is question 5.1. Let's answer here. The gravitational potential energy is equal to the product of mass, acceleration due to gravity, multiplied by height. Quite simple. And the formulas are here. They give you the formulas. In this case, here is the formula for gravitational potential energy. Somewhere people use U instead of EP. It's also accepted. So we are here. You have everything. All you have to do is to substitute. This one is 68 multiplied by 9,8 multiplied by 50. And this one is telling you that the gravitational potential energy of the man there is going to be 33,320 joules. That one is question 5.1. If you answer that one correct, you will get the first 3 marks of this question. One there, one here, and one for the answer. It's quite simple. State the law of conservation of mechanical energy. Very important even for grade 12. And all we have to say here is that the total mechanical energy of an isolated system remains constant. There is 2 marks for that one, guys. Important, the word total mechanical energy is very important here, an isolated system. If you miss any of those words, you will not get the mark. Use the law in question 5.2 to calculate the velocity of the man at the height of 20 meters below the bridge. So they want to know below the bridge, 20 meters below the bridge. It means they want you to calculate the velocity of the man when the object or that person is right here. Is 20 meters below the bridge. This is 20 meters from here. It means that from the ground is going to be 30 meters. Alright? So it's 30 meters from the ground. That is what they want to calculate the velocity there. For this one, they said use the law, and that is what we are going to do. We're going to use the law here. You can see the logo of the website from where I download the question paper. You can go there and download more question papers there. So let's answer this question here, 5.3. We have to use the law. Now, to begin with this law, we're going to say that the change in mechanical energy is equal to 0. It means that the total mechanical energy initial is equal to the total mechanical energy final. You have to remember that mechanical energy is equal to kinetic energy plus potential energy. This is an important thing you need to remember because you are going to substitute in there on each side. So you come here and you say mechanical energy initial is the addition of kinetic energy initial plus potential energy initial, and this is equal to kinetic energy final plus potential energy final. Now, important to organize our work. All this initial is referred to top of the bridge. Okay, so all this one here, which I'm going to move here, is going to be top of the bridge. That is our initial. And our final is going to be 20 meters below the bridge. Okay, so those are the initials and the final. And now we are going to substitute the formula. Remember, potential energy, kinetic energy is half mass multiplied by v squared, speed squared, and potential energy is mass acceleration due to gravity multiplied by height. Alright, so we're going to substitute these formulas with the respective one. So we come in here for kinetic energy initial, we say half mass speed initial square, that one is on top of the building, plus potential energy, but we already did calculate the potential energy on the top of the building, so we don't have to substitute the formula. Okay, so we're going to keep here potential energy initial. Now kinetic energy final is half mass speed square, that one is going to be, remember, 30 meters from the ground, okay, or 20 below the bridge, plus mass acceleration due to gravity height. And then the rest, guys, is to substitute. We have everything, so let's substitute the numbers, the numerical value. This one is half the mass of the men, because they want to know for the men it was 68, so we substitute here is 68. The initial velocity is 0. All right, the initial velocity is 0. The man was standing there with 0 velocity right on top of the bridge. Plus, this one is known by us. It is 33,320. This is equal to half. Mass is 68. This V is what we are looking for. Plus 68 multiplied by the 9,8. Now height from the ground is going to be 30 meters. Be careful with that one. And the rest is calculation. So for instance, you can see that this one is 0 because every number multiplied by 0 is 0. So what we have, 33,320 equal to 34 v squared plus, and here you will get 19,992. Guys, the rest is to rearrange this one. We can quickly do it if you want. Let's do 33,320 minus, this one is positive, is go negative to the other side. Okay, so it's minus 19,992, and this is equal to 34 v squared. Let me move this one here, I don't want to be right on the edge. V squared, and then you get that this is 13,328 equal to 34 v squared. Okay, let's finish that one. Let's write it down here. Let's write it down there on top there. We have 13,000. Okay, let's write it here. 13,328 equal to 34 v squared. Is that so? Yes. Yes. So here v squared is equal to 13,328 divided by 34. So v squared is equal to 392. But now this is the square, so v is equal to the square root of 392. I'm doing step by step, guys, in case somebody don't understand. So the final speed is 19,8 meters per second. That is the answer. All this one is just a calculation. Okay, so if you come back here and you substitute now, you come here, if you go to the mark, let's give marks here, 1 for the law. When they say the law, it means that you can get 1 mark for any of this one. All that one start the law, even that one here. Let's take it all there. Alright, then you will get 1 mark for the substitution on this side, 1 mark for this substitution, 1 for this substitution as well. And then, guys, the final mark. Now they're asking you for velocity. Velocity have a direction. You know the man is moving down, so at that specific point is moving down, so you will get that mark, but you must write here downwards or just down. And that is the end of this question, guys. I hope it helped. It's a good question. Thank you for watching. Thumb up, subscribe for the channel. I'll see you next time. Mr. G here.